Hi everyone, good afternoon. Hope you're enjoying your lunch. Just someone give me a thumbs up so I know you can see my screen. Thank you, Lily. So yeah, my name's Matt. I'm part of the Connox team here in North Europe. We also look after Australia randomly, and Lily, really good to have Lily here. One of our superstars from our product team. So Lily's going to do the majority of this overview and kind of really dive deep into some of the things we're going to talk about. So um, bear with me for a few minutes. I will kind of give you an overview of Connox, what we're doing in the UK in particular, some of the stuff that kind of separates us from that more basic void meeting type technology, and then we will dive into some of the really good, interesting stuff. So just to begin, if I just jump slides. So Connox, additionally, we monitor at both the switch and the crossing, as hopefully you can see from the graphic on the screen, although it isn't updating for me. I don't know what you guys can see, but basically trains run over the S&C. Every axle is recorded by the yellow box. I'm hoping you can see what I'm seeing. Then all the data is sent up to the cloud. From there, that's where our really sort of clever processing pipelines and analytics comes in. So we can also augment the readings from our sensors with things like PWI data from radar, for example, or radar 2 to give that more holistic view. But for today, we are mainly focusing on the track element and the kind of Connox IoT device. So I will now jump on, so that's working. Just a bit of background on who we are and where we've come from. We're kind of approaching 6,000 units. So we've got about 4,000 in Deutsche Bahn over in Germany. We have rollouts with a diff in Spain. We're doing stuff with Infobel in Belgium. And we are starting to put stuff on the ground in America, which is really exciting and kind of opens up some new use cases for us. And hopefully later this year, we'll have some stuff in Australia. But for the UK, we attained full product acceptance around about August 2021. We had a really exciting update, sort of Q2 this year, which is the ability to install the units through drilling. Probably doesn't sound that exciting to a lot of you, but for us it really is. It basically means we can install the units in one site visit in about 10 to 15 minutes. So as you can see from the diagram on the right, or the image, we basically drill into the bearer in a very controlled way, making sure to avoid all the strands and doing it, really safely and controlled. Base plate goes down, device goes on top. Once we have the device installed, it is fit and forget, which is fantastic. So the battery life lasts between sort of 5 and 6 years. So we are seeing battery life exceeding sort of that 5 years, which is brilliant because it is really then fit and forget. Line speed wise, we can operate between 25 miles per hour to 200 really comfortably. Obviously, we're not hitting 200 miles per hour over here yet, but we do over in Germany, which is fantastic. We can go lower than 25 miles per hour, and we are working on a sort of longer term solution out of the box, which will mean we can get much lower speeds. We can localize assets as well. So if you have a line speed of say 15 miles per hour in and out some of these key stations, we can tailor the unit to be able to deal with that, but it just requires a little bit of configuration and localization just to make sure we deliver the best quality data and results that we can. Ultimately, it can be fitted to any ballasted S&C. As you saw from the previous diagram, we generally monitor at the switch on about bearer 2 or 3, and at the crossing right at the nose, right in the middle of the forefoot. We have got some plain line sites as well, so we have looked at things like IBJs, we've looked at flying ends on bridges, but ultimately being able to monitor the sort of more basic stuff really keeps you compliant with that 054 standard. So making sure we can check sort of the displacement under load is absolutely key. So it really does help with that kind of compliance piece. So where are we in the UK? What does it look like currently? So this is obviously very network rail focused. We are doing installs with TfL. We have got stuff out in Ireland. We talked about Infobel and others already. But this is basically the breakdown of where we have coverage in the UK. And that screenshot on the left is directly from our UI. You can see a nice spread of assets, and they are flagged as red, amber, green. And we'll come on to some of this in a bit more detail in a minute. But we are approaching 2,000 units, which is fantastic. At the moment, we've got about 1,000 installed. So we have about 800 left to install. But we have really good coverage across, all routes and regions now. So that knowledge bank and that knowledge graph in the UK is really, really growing. So today, what we want to talk to you about is kind of what makes the Connaught solution more than just a void meter. And yes, it will help with your displacement insights. It will give you displacement predictions. That's already bringing AI into this. The track bed health is also there as well. We are looking at train speed, as I was describing earlier, because the IoT device records every axle of every train that goes over it. We can then really work out the speed of what trains are going over. We can classify them to understand, is it those big heavy freight trains, or is it the quick passenger trains that are causing the most issues and degradation? We can then look at tonnage as well. So from the box, we can then also derive.
Have you finished with Mr. Mike?
Hello? I think someone's not on mute. We will carry on. So obviously very excited.
Matt, you're on mute.
Yeah, I managed to get muted then somehow. So I guess someone was quite excited about the tonnage stuff. So yeah, so the box will record every axle. We can then turn that into things like tonnage readings and speed and train classifiers. We can also evaluate all the effectiveness of maintenance. So every time someone goes out on track and does an intervention, we can then really see the effect of that, whether that's had a positive effect, whether that is sustained over a long period of time, or whether the asset returns to where it was. We've also seen some really interesting examples of where interventions have had a negative effect on the asset, which is really, really key. And that's not the sort of stuff we can see just by monitoring displacement or voiding alone. Today, I'm going to talk to you a little bit about stuff like wheel trajectory and relative acceleration. This is what we would refer to as kind of advanced features that really open sort of other avenues and really give us that deep level of understanding. And then obviously Lily's going to show you how we take that even further to do some really clever stuff. So what I'm going to do now, just give you a quick overview on a couple of those advanced features I just mentioned. So the first one being relative acceleration. Traditionally, because we're using accelerometers, we can provide displacement pretty accurately or very accurately. We can also give you the amount of acceleration or the amount of impact loading going through your crossing, for example. But what we have to understand is where 5G is a problem for one type of asset, a 7G might not be a problem for another type. So what we're trying to understand is what makes an asset look good or bad, because we don't want to be reporting all the time that 5G, you need to go out and do something, 7G, forget about it, or can we go up to 9G? So what we've tried to do, and the example on the screen here is a 1 in 27 crossing. We will take, for example, all the 1 in 27 crossings. We will then look at the bearer construction type. So is it on wood? Is it on concrete? That will have less of a weighting than, say, the crossing angle. And then we'll also then apply train speed. So what we would then do is benchmark all the assets. So we can then tell you that actually 7G for 1 in 27 crossing on a concrete bearer at 80 miles per hour is okay. We don't need to worry about it. Whereas 5G on a different asset could cause us problems where we need to go out and intervene. So it's about taking the kind of data, the acceleration information, and making it smarter so people can make better informed decision. So here's a really good example of that. If I just jump onto my next slide. So this screenshot on the right is directly taken from our UI. The blue line across the top shows the displacement. The line at the bottom, the orangey line, shows the accelerations, the amount of impact loading or the impact forces going through that crossing nose. As you can see, it's sitting well below the 7 mil in the standard, but it is sitting above the 4 mil in terms of displacement that we would start alerting at. However, a relative acceleration or 7.8 G sounds moderately high, not overly high, not too low, probably not a massive concern. When we look at its benchmarking in terms of the relative acceleration for a crossing at a similar angle, on a similar speed, on a similar construction type, we can see that it's performing 423% higher than we would expect. To me, that would start raising alarm bells. So looking at basic displacement data alone, or looking at just acceleration alone, which is a kind of a new metric, we've managed to benchmark it, which means we can take the right action. This really helps us move towards that risk-based maintenance approach, because we're not sat there thinking it's fine, it's at 7G, it's at 4 mil, everything's good. We can really understand. The inverse can happen as well. So where we might have reacted before and gone out and inspected, we can now actually decide not to, or to delay the intervention, because we know that asset can sit at this kind of forces for longer. So this is some of the kind of stuff we're looking to introduce. Another really, really key feature is what we would call wheel trajectory reconstruction. This basically almost gives us a laser scan every time a train goes over a unit. This will from the little vibrations from our accelerometer and our IoT device in the middle of the truck, we can work out the trajectory that wheel is taking through that crossing nose, whether it's transitioning from the wing rail onto the nose or the nose to the wing rail. We can then see where it's kind of loading, unloading, where the dip angle is, and if there's any anomalies. So this is, almost overlaying it to a kinematic type envelope. Here are two examples, and I'll give a little bit of context to these in a minute. The one at the top looks pretty good. So if we look on the left-hand axis, we're looking at millimeters, so the amount of displacement or movement up and down, and then the distance along the crossing nose. As you can quite clearly see, it's going from about 2 mil down, obviously through that transition point between the wing and the nose, or the nose and the wing, and then back out in kind of a smooth pattern. The example on the bottom is coming in a lot higher, so about 5 mil, coming in fairly steep, but you can see there's that double kind of hit, where the wheel is obviously hitting, unloading, hitting again. It's almost like it's having a double impact as it's transitioning across. To me, that would indicate there's some sort of error or some sort of problem developing on that nose. To give that a little bit more context, what we are looking to do, and when I say we, I mean Lily and the product team. So what we're looking to do at Connox is kind of turn that into a more meaningful visual and metric. So we're hoping to build dip angle into this reading soon. So putting it into millirads, which is a term a lot of the network crowd colleagues will be familiar with. And then we're looking at being able to then derive the amount of kilonewtons in impact force. There's a really good article that was written by some of our engineers that came out in the PWI journal. I think it was June or July this year. If you've not read it, it goes into this in a lot more detail. So pick up that journal, have a read. Really good article by a couple of our team. As you can see from the image on the screen, that kind of impact force and where it's taking place can really lead to us to understand what we need to do. Is there a severe dip angle? Is there a high force? Why is there a high force? Is there a contact loss? Why is that taking place? So it really helps us understand, what all these metrics mean. Why are we getting high forces? Why are we getting a high relative acceleration? So it helps to really add some context to it. Just before we kind of move on, here is a screenshot again from our UI. As you can see from the one at the top, this is our wheel trajectory feature, and again, displacement in mils on the left and the distance along the nose along the bottom. You can see it's coming in fairly steep at the end, but then there's this double hit as the wheels transitioning. We've also done an integration with One Big Circle, so using their AVA system. So if we were to go into our UI, you can see below your wheel trajectory a downward facing bit of imagery as provided by One Big Circle and AVA. From there, it really helps give some context to what's happening in that wheel trajectory. So as we can see, there's a really short wheel transition from that crossing nose onto the wing rail, and we can see a lot of unloading taking place, which pretty much replicates what's happening above. So as we can see from a wheel trajectory feature as it is today, aligned with the imagery, we get a really clear visual as to what the defect is. So just a bit of high level summary then. So we believe, looking at historic RDMS and FMS data, so defects and faults, we believe we can detect 50% more defects than Boyden alone. We have looked at some metrics historically as well. So we have detected 80 to 100% of broken crossings at least 28 days in advance of them happening, but also 78 to 80% of defects as well. So if we'd have reacted to the data prior to the defect occurring at least 28 days in advance, we could have maybe eliminated up to 80% of them, which is pretty significant. So building, the basic with the advanced features we've just discussed, we're starting to really kind of move that dial. In monitoring delay minute terms, that equates to about 65% of S&C delay minutes, including the stuff for the point machines as well. So we are having a real significant impact, which is great. And then finally, a little bit on alerts and alarms. We don't want to be a system that kind of scrambles people all the time because we're sending too many alerts and alarms. So we have set out some sort of rough benchmarking. I guess the key one for me is there's different benchmarking at the crossing and the switch, as you would expect. But that relative acceleration means rather than just sort of saying 5G or 2G, we can start saying actually alarm at 200% because someone else's 3G is different to someone else's 4G. So it's understanding where it all benchmarks. Some teams have put work instructions in place where they use Teams to triage the data. From there, they will go out and react accordingly. So whether they carry out a full 054, do a desktop exercise, obviously that does depend on the track category. So a lot of this alerting and alarming will lead to sort of the right intervention taking place. An example here is a lift and pack, which we can see took place. The system started to monitor the effectiveness of it and has it been sustained for a longer period of time rather than, for example, doing a lift and pack and the track returns to where it was 5 days ago, or it didn't have a significant impact. So being able to evaluate what we do and how we do it is absolutely key to that feedback loop as well, and really does help us move to those, risk-based systems. Finally, this is where Lily's going to take over in a minute. I'm sure you're all pleased to hear that. So we do a lot with what we call asset scoring as well. So we look at a combination of what is the displacement, what is the relative acceleration, what else is happening. We score them, then we can start ranking assets. The idea behind this is we're trying to understand, obviously, if we monitor every S&C, half of it will tell us, it's okay, you don't need to worry about it. But the other half might start to say, we've got problems, we need to go out and do something. In a realistic world, people can't go out and look at every asset a system raises. So it's understanding what is the priority this week, what is the priority this month, what is my top 10% I need to look at, what are the top 5 assets I need to worry about because they're going to cause me significant problems. So it's trying to benchmark all of this data together to give some metrics and how we react as human beings, which is where Lily is going to take over and hopefully dive into some of this in a bit more detail. So I will stop sharing my screen. That was a really quick high-level overview. Thank you for your time. Any questions, please raise them. And over to you, Lily.
Thank you so much, Matt. So yeah, hello again, everybody. My name's Lily. I'm a senior product manager with Konex. It's a pleasure to join forces today with Matt and the amazing PWI team to host this session for you guys. As Matt mentioned, today I will show you around some of our more recent developments with the product. So I'm gonna share my screen for you in a moment. And I would love to hear what you think. What are your favorite bits of it? Maybe some changes you would like to see in the system. Yeah, but without further ado, I will start sharing my screen. And here's a sneak peek into the Konex dashboard. So as you see, it's called the new experience and it has a beta tag on it. So as you might guess, this experience is currently only available to our beta users. If you're from the Network Rel team and you're interested in getting access to it, please feel free to contact our team. As Matt mentioned earlier, our colleagues have been communicating through reporting with our users and customers with the Network Rel. These reports proved very, very successful. The customers really appreciated the prioritization, being able to see the order of the assets based on how much they need attention or how urgently they need attention. So we took this idea from the product team and we spent the past year closely working with some of our EU-based customers to turn it into a product feature. During the development process, we kept our main focus on 2 major groups of our users. One group are users who work in what's called as control rooms. This concept exists similarly across all of our customers, one way or the other. These are people whose job is to sit in a room, look at our platform, and see what are urgent cases that need immediate reactions. So these are cases that Matt already talked about a little bit. We call them either critical alerts or warnings, depending on the amount of attention that they need. So the only point of information that these people need to know is what needs quick reaction immediately so they can issue a work order. The second group of users that was of interest for us were asset managers, infrastructure managers, people who are responsible for planning resources, planning finances over the year, planning maintenance activities. These people need to have an overview of how their assets are doing over the long term, and what are the highest priorities if they have to. Obviously, like, we never have enough resources to attend to everything all at once, so how can they prioritize within that? So the feature that we developed for the people in the control rooms waiting to see cases that need immediate and urgent reaction was the alerts widget. You see it here on our dashboard. Right now it's filled with info alerts, which are cases where we do not think an urgent action is required, but we still think are worthy of attention. We see that within the network rel network right now, we have 2 warnings, 2 cases where we think are worth going out and inspecting within the next couple of weeks. We know that people working in control rooms, responsible for reacting to alerts and alarms, they're super underwater with all sorts of platforms and different interfaces that they have to look at. So we try to keep our alerts and warnings as minimal as possible. So we try to flag only cases that really genuinely need attention within the next couple of weeks or within the next couple of days. Thankfully, we see that right now across the network rel network, we do not have any critical alerts that need attention within the next couple of days, only 2 more minor cases. So just to show you guys a little bit how the alerting system works. So we see alerts as bits of our product that really have an end-to-end life cycle from the moment that they are issued based on the changes tracked within our system. We keep looking at them until the point of time where an inspection is issued. Then after the inspection, maybe a maintenance is issued, maybe not. If a maintenance is issued, that is entered within our system again, until the point that even required maintenance is done and an alert is closed. If an alert is issued and no one reacts to it, maybe because of some local wisdom that they think it doesn't need any attention, or maybe because they already have activities like exchanges planned, then they simply expire after 90 days. So they won't stick around forever as well. So we hope that by providing this feature, we give everybody, all of the stakeholders, different teams involved in the overall life cycle of an alert from the moment that it is issued until the moment that the root cause is resolved. They get clarity on what's going on with this alert and what's happening to it, who's reacting to it. So that's a little bit on what we designed for people responsible for reacting to urgent cases within control rooms. Now I want to dive a little bit deeper into the idea of track priority list. I talked about infrastructure managers, asset managers, people who are responsible for planning funding, planning resources, planning personnel for going out and doing maintenance. What they need is a real-time prioritized list of their assets based on how much attention do they need, right? For that, we have this priority list available, which is supposed to be a ranked overview of all of their assets. Always on top, you have critical alerts, which are assets, as I mentioned earlier, that need attention within the next couple of days. In this case, we don't have that. Then we have warnings, which, as I mentioned earlier, again, are assets that need attention within the next couple of weeks. And then we have the rest of the assets basically rated based on how much attention do they need over the longer term. The way we sort these is based on a score called asset reliability. So this is another place where the smart AI comes in. We take in a lot of different factors like relative acceleration that Matt talked about a little bit earlier on, vertical displacement. Also, in very close future, the insights we have from wheel trajectory reconstruction to combine together and come up with this score called asset reliability. And this smart asset reliability score is supposed to tell us the likelihood of the asset failing within the next 4 months. So basically, this number shows you how quickly is your asset degrading over time and gives you hopefully a useful long-term perspective towards how your asset is doing in general and whether it needs attention sooner or later. And having the number here gives you the possibility to compare one by one. Yeah, sometimes, the decision comes down to choosing between two assets. For example, you can only maintain, I don't know, 4 assets that are not experiencing any alerts. You see that you have this ranked number 3 with like 48% reliability, 79% reliability, 80% reliability, 80% reliability. And here is where you have to cut the line. Here is like where you can no longer maintain in the closer future. So the number gives you clarity and the possibility to compare assets one by one. Another interesting feature that you see here is maintenance recommendations. So we have, since a couple months ago, we have taken a step even above and beyond just being predictive, so predicting what maintenance is required, and going towards prescriptive. So with our maintenance recommendations feature, we are able to tell you on the majority of your assets what type of maintenance is required on trackbed or superstructure. We also provide you the degree of confidence that we have for these recommendations. As if you're familiar with AI applications, you know that the data is not always complete that is feeding into these machines. So sometimes the decisions that the machine can come up with are not super confident. As we see here, the decisions are luckily confident both, but we provide the confidence level to assist you in having clarity on how much you can trust these prescriptions, these decision assistant insights provided to you by our system. These two features, so the maintenance recommendations and asset reliability, as I told you, are powered by artificial intelligence, meaning that they can only become more and more powerful. So over time, they are learning from the ground truth data, from the data that we learn from inspections that are done, maintenance that is done. They become more and more powerful, learn from their past decisions, but also we can continue including in further factors, further decision makers to make them even more smart, right? So for now, for example, we have vertical displacement, relative acceleration, the amount of load on the asset to decide what the reliability will be, what is the likelihood of the asset failing over the next 4 months. But over time, we will be able to include even more factors that help this decision making. So for example, it is very, very interesting for us to learn more from you guys what other factors help you make decisions about longer term reliability of the assets in your hands. Another topic that I wanted to tell you guys a little bit more about is the asset details page. So for each asset, you will be able to see a specialized page. Matt showed you a little bit of this before. So you see the diagrams where you can see vertical displacement and acceleration changing over time. You can see the alerts mapped on the graph. So you can see when exactly did they happen, and you can see patterns that led to those alarms. You can also see maintenance activities, the reasoning behind them, also provided to you by AI over here. So wheel trajectory we talked about a little bit before. So the idea is basically reconstructing the way that the wheel moves over that bit of track. It helps you identify root causes. In the next couple months, we will add even more insights like dip angle and impact force to make this feature even more useful to address your decision making. Overline imagery Matt showed you already. But one feature that I'm very, very excited to show you all is the asset timeline. So the idea behind asset timeline is very, very simple. It is supposed to be one single source of truth for your asset. Call it like some sort of archive of everything we know about your asset so far. Why is this important? The more we talk to our customers, the more we realize that our customers are always overwhelmed about the fact that they have to check multiple different platforms to get little bits of information to address one single decision. The goal of the asset timeline is to put all of these information in one place, make them available in one place. So make you needless of going through all sorts of different platforms to get all of the information that you need. Here you can see a record of different alerts that happen to this asset, also maintenance activities that we can automatically detect or can be entered by the customer, by the user into our system. We see those. We also see things called asset notes, and these are notes that are collected from maintenance activities that were done or notes from inspections. data from our DMS, as you can see here, are all available to you. Whatever ground truth data, whatever data from the field that is available to us, we will automatically inject into this asset timeline to make it available for our customers in one place as well. One last thing that I would like to show you guys is our maintenance activities page. So as I told you a little bit earlier on, we do detect automatically whether maintenance was done or not. Our users have the opportunity to review these detected activities and either confirm them or reject them. They can also add their own maintenance activity, as you see. But what's really, really amazing is that we're using the smart intelligence here, the AI here, to decide whether maintenance activities were actually effective over time. So over windows of a couple days, 2-3 weeks, we give you results whether the maintenance activity was impactful, or maybe it even like made the situation worse and now the asset needs more attention. So this is, one feature that our customers are often quite excited about, and we're working on developing even further. So this is a little bit about features that we developed for people who need to react immediately to urgent cases, features that we developed for people who are responsible for longer term planning, for looking at maintenance activities. I would like to close my bit of the session with taking a look at the map. So Matt also showed you a little bit around it in the beginning of his presentation. It's quite a simple idea. We have little dots for every single asset. The dots are currently color-coded based on the level of criticality. We're working on improving our map experience. But the main use case of the map is for people to be able to take a look at it and in one go be able to tell if it is worth it to, for example, bundle this asset's maintenance with this other asset's inspection. We know that people who go out on track, people who go out on the field, they're very overworked. They have to go out sometimes at odd hours. It's not always very easy to find windows where the track will be available without disturbing the traffic. So, for example, if Lily is planning to go out and inspect this morning, she sees that this other asset close to it has low reliability and needs a little bit of inspection. She might bundle them together to do it all at once. So this is the main use case we're trying to address with our map as well. And we're hoping that it improves our users' lives at least a little bit. In general,
where have you got these? Sorry, are these on the Midland Main Line? Any of them?
Sorry, can you please repeat? I had a little bit of trouble hearing you.
Do you have any of these little boxes on the Midland Main Line? I can't really see from the map.
Yeah. You can zoom in and. Sorry, my laptop's acting out. But yeah, the more you zoom in, you can see, and also once you go into the asset details page, you can see where exactly the asset is located on the little map section over here.
So these are rolled out on quite a few routes up and down the country.
Yeah. Exactly.
Yeah, so what you can also do is filter by regions as well. So so you can filter by your region, DU, TME area, whatever you need to do. So you can see, I mean, as I said at the start, we've got just over 1,000 on the ground. We've got about another 800 plus to install. So we're about to have 2,000. We've got good coverage across most routes. But yeah, you can drill down to this level, or if you're working in a particular route or in a particular section, you can just have access to those assets because you don't really want to see everything else, I suppose. But yeah,
how long have they been on the ground?
Sorry, Robert, if you wouldn't mind, I think if you wouldn't mind just letting Lily finish off the, or you.
I'm actually
done?
no worries, because I'm nearly done, and I think actually this is perfect time for questions.
Okay, perfect. All right, no worries.
Yeah, we'll dive into it. Lily, I'll take that one as well if you want. So how long have they been on the ground? I mean, yeah, that varies. So the longest assets we've had in the UK have been down probably approaching 4 years now. Some routes like the East Coast, for example, are installing a few hundred at the moment. South Wales has had them down for quite a while. So it would depend on which asset, but some have been down a few months, some have been down a few years.
Yeah. Okay. Thank you.
I mean, if you want to know more, feel free to send me an email. I can set up a session with just yourself and your teams, and we can go through your individual area and use cases. That's absolutely fine.
Okay. Thanks.
Fantastic, thank you. Yeah, any further ideas, maybe bits and pieces that you liked about what you saw so far, or maybe any open questions so far, bits and pieces that you didn't like that much that you can also tell us about?
Great.
Okay,
have you finished? No, Lily. I just
yeah, I'm
want to
done
double
with
check.
my part.
Perfect.
Yeah.
Thank you so much, Lily and Matt. That was really informative. If we're able to give both Matt and Lily a virtual round of applause. We will now go into questions, and Robert, thank you for starting us off. We've got a couple in the chat, but I will give people the option to put up their hand as well. So if you would like to ask a question to either Lily or Matt, please raise your hands. I can't see any hands raised for now, but there are a couple of questions in the chat, so I'll take those first then. So start with Madan's question, which I think you kind of answered through your presentation, but if you want to just build on it. So the question is around what kind of defects do you get, and what do they compare to? And can you only use the system on switches and crossings?
So the type of defects that we can detect, obviously your normal sort of, breakout squats, things like that. When Lily does her prioritized list and their kind of reliability score, I'm not sure how they do the comparison like for like with other similar defects or how that forms part of the modeling. But all the usual sort of stuff we would expect, I guess a lot of it depends. The system will tell you something is wrong, but then you would have to again go and classify that is this defect or this fault. We will get better at identifying that in advance to tell you we believe this is the defect that is starting to occur, and that's obviously based on having sort of nearly 6,000 units on the ground. And what is it, Lily? Something like 500 million data traces. I mean, it is significant now, isn't it?
Yeah, exactly. I mean, pretty accurate answer from Matt. Yeah, thank you. Just to add a little bit on top of it. So as Matt mentioned, right now we can tell you that something is wrong and you have to go take a look at it. But it is part of our product strategy going forward to kind of couple the insights that we have together with any sort of visual information we can get or any other mediums of information we can collect from the field to be able to exactly tell you what is the root cause and what type of action needs to be taken. So that is part of our roadmap for the upcoming year.
That's
then
great.
do you want me to answer the second point? So we monitor the switch and monitor turnouts. We have monitored fixed diamonds and various other scenarios. I know in a diff in Spain, we monitor swing noses as well. So where the actual nose moves. So yeah, we can monitor various different configurations and setups and asset types. We have done some plain line, and we have looked at expansion joints and things like that. The plain line use cases aren't as well developed or known, but yeah, any sort of switch diamond crossing S&C, we have probably got a comparable asset we're monitoring somewhere across Europe. So yeah, we do cater for quite a lot.
Great, thank you. Next question is from Barbara. She thanks you for the presentation, and I think she's particularly interested in prioritizing short and medium term maintenance. How do you think this could support the prioritization of longer term turnout renewal and around the kind of the 5-year horizon? Also, are you able to use the product in yards with low speed?
Okay, so to answer your first question, thank you so much for the feedback first. I have very good news because right now we are actually currently doing the research to kind of be able to predict turnout renewals, and we're pretty much almost there, ready to roll this out. I'm happy to see that there's interest in it also. And honestly, Barbara, happy to talk to you a little bit more maybe later about what type of insights do you guys exactly expect? How can we help you guys better with these type of insights? Because we're working on it right now. Yeah.
Thank you, Barbara. And thank you, Lily, for answering the question. The next one's from Oscar Khan. So I think through the presentation, we saw some footage from kind of Ava and One Big Circle. So I guess the question kind of builds on that. How easily can the Connex platform integrate with future kind of network rail, network model platforms and other sorts of, I guess, future platforms?
Yeah, the answer is really easily. We have built the system based on data sharing, and we have a system called Delta Share, which basically means people can take the data from the back end of our system with a token. So, for example, we've got ongoing conversations to integrate with Insight. We have integrated with the One Big Circle system, as you've seen, Ava. We're taking data in and pushing it to their system, or they're pulling it from our system. I know with Deutsche Bahn, you do a lot via SAP systems. So yeah, we would easily be able to send our data to many different systems. So it's an open access system. Lily will give you the technical details better than I can, but that's exactly the culture of kind of the way we've built the system and our ethos about if we can give a frontline user a better, and it's a bit of a buzzword, but a better holistic view of what's taking place. And that might mean taking data from various different places. It might mean sending our data to other places. Absolutely fantastic, because that's what we're all here to do, right? So yeah, I think we can easily do that.
And that's great to hear. I hear more and more that companies are offering that kind of open API type product to allow people to share. So that's great. The next question is from Mark Loughton. So again, thanking you for the presentation. Have you looked into how your technology compares to the information provided by fiber optics monitoring?
Lily, do you want to take this, or do you want me to answer it?
Go for it, Matt.
Thank you. Fiber optics is an interesting one, so it depends on the context of what you're exactly referring to. I am familiar with quite a few of the fiber optic products out there, but there might be one in particular you're talking about. And again, it probably goes back to the answer I just gave about if that fiber system is detecting something different to us and we can build it together or share the data together to give that more rounded view, fantastic. In terms of the amount of force and stuff going through it, I don't know. Like, I haven't seen one that does a direct comparison, really. So if you want to provide more information, we'd quite happily look at it, because it sounds like there's an opportunity here. But I don't know directly with the system you're referring to. I can't think of one that would do a direct replacement, unless I've misunderstood the question.
No, thank you for that. I think it's probably worth having a separate conversation, and there might be something there. So.
Yeah, happy. Yeah, so, you'll have my details after this presentation, so more than happy to have a chat about it.
Cool, thank you.
Right, thanks, Mark. And the next question is from Andy Folds. Have you found any patterns in relation to the time between an initial warning and a subsequent move to requiring attention?
Yes, actually. So one thing that is very, very important for us in Connex is to continuously monitor the performance of our models. So as we have developed and rolled out this whole setup for critical alerts and warnings, we're now monitoring how the assets are doing once warnings are issued or critical alerts are issued, what's happening to the asset. We had already a couple cases within Germany with Deutsche Bahn that we went out and inspected. Also one case within Network Rail, actually, where we learned that an exchange was planned for a couple weeks later than that already. So the system was definitely seeing something. Also within Deutsche Bahn, we saw that, especially in one of the cases, it was really interesting because we did have a warning and insisted to see like how the team was reacting, and they were like, yeah, don't worry, like we know this asset, nothing is going to happen to it. Boom, a couple weeks later the asset actually broke and they had to do like an emergency exchange. So yeah, but we're seeing some success stories and very happy to share them in more detail with you in separate calls or conversations.
Right, thank you, Lily. The next question is from Stuart Corrie or Corrie Stewart, I'm not sure, apologies. Do you have any plans for custom bearers with base plates pre-installed to allow measurement from installation?
Absolutely. So this is something we've already done, where we can be proactive and we can find out in advance of a renewal taking place. For example, we have worked with companies such as Cemex to get our units precast into the bearers. So then when they do the layouts, our units are ready to go. So Kennet Loop in Reading is one area we've done it. There are 2 or 3 others. It's really nice. We can either install the units in the yard or would wait till the ballast drop had taken place and we'd come along and whack our units down. But it's in a precast insert, so we literally 30 seconds screw it down. What that gives you is monitoring from day one. So perhaps you can do a quicker hand back at line speed because you can see everything is as expected. So the sort of scenarios we've looked at, obviously it's really nice for us, and maybe in 10 years we can have a really good conversation about degradation modeling. Because of the stuff we're kind of doing, we can look at the amount of impact force going through these units and we can understand the annual tonnage. So we've started to get really good at kind of doing that longer term planning and those whole degradation patterns. And this is something Lily and the team and our data scientists are really sort of big on. This is kind of degradation and life expectancy, which is why that asset health reliability score is so important. And on a brand new layout from day one, yeah, it's going to be amazing to see how that pans out in year, 5, 10, 15, 20, 25. So yeah, but we have done it and it is something we will definitely do. So if anyone's doing any renewals, give us a shout and we'll get the stuff precast where we can.
Great, that's really good to know. I'll take the next 2 questions together. So from Mohammed and Jordan, what is the sample rate of the measurements, and have you found any differences in data between sleeper types in S&C?
So maybe to first answer the question about the sample rate. So over all of our feature sets, the sample rate currently is 500 Hertz. We have worked on reducing it to 100 Hertz for all of our core features. We're now working on even expanding that to some of our advanced features that Matt talked about a little bit earlier. So yeah, that is an answer to the first question. Have you found many differences in data between sleeper types in S&C? Matt, is that something you would like to touch on?
Yeah, I mean, not as big. There are other factors which play a bigger part, but obviously as part of that relative acceleration, as an example, one of the factors we benchmark against is sleeper type. So mainly difference between sort of wood, composite, concrete. But there are factors which play a bigger part, such as turnout angle, line speed. So it's something we probably have noticed, but it doesn't play a bigger part as other critical factors. But if there's something you're thinking of, or you've got an individual case you want us to look at, we can definitely look at the data and sort of drill down even further into that. So yeah, more than happy to pick that up.
Great, thanks, Matt. The next question is around AI, and I think I wanted to ask a little bit about this as well. So how much AI generated data is trustworthy and dependable enough for users to rely on when making important decisions? And then I think for me, so obviously when you put your product in from the first day, when do you get to that confidence? Because obviously it's machine learning and it takes time. What have you seen where you feel like you've got confident data?
So the luxury that we have with our 8 years of experience out in the field is that, as Matt mentioned earlier, we have more than 500 traces of data already, 500 million. Oh my gosh, not 500. 500 million traces of data already available to us, right? So when we're like looking at the data available to us to learn and make like AI-based decision making, right? We're not only looking at the data collected specifically from one single asset. Of course, locally speaking, assets, depending on the conditions that they're installed in, they're going to have their own special characteristics, so to say. So we will need a couple weeks to learn about what does this data mean for this very specific asset. We need a couple weeks for that, but it doesn't mean that we're starting blindly, so to say. To address Khoshnas's question about how much AI-generated data is trustworthy. So, I mean, might sound cheesy and repetitive, but the more the better, right? what we can do when it comes to AI applications is that we can take what we have, and based on everything we know about the history of an asset and all of the asset histories available to us, we can come up with a confidence level. So even if we do not have perfect ground truth data to make a decision with like 100% certainty, we can still tell you, okay, but we're 80% sure that like this is the action that you need to do next. Or like we're 90% sure that you're going to have to take a look at this within the next 4 months if you don't want it to break. So yeah, I hope at least that answers your question a little bit.
Thank you, Lily.
Yes, thank you, Lily.
Great. There are a couple more questions, and there's lots of people thanking you for your presentation and for answering your questions. The next question is from Les Biggs. Is there any data available on train types that may be causing damage to S&C units?
Yeah, thank you for the question, Liz. Les. I do know Les, by the way, so I called him the wrong name. I think I'll get away with it. There is, because we record every axle of every train and we aggregate that up into one train movement, we fully understand the train. So when we dive into the system, we can go into a view called Trace Explorer, which basically shows us a dot for every train. From there, we can filter down into train types. So we can then really start to see, is that the freight trains? Is that the passenger trains? Is it a particular class of train, for example? So we can understand which one's pulling the higher forces or which one's hitting the units a bit differently. So we can drill that down and review into it. Especially this becomes really, useful if we're looking at, are we going to put on an extra few passenger services on this line? Is there a new freight line opening up? Are we actually hitting the annual tonnage on freight we're expecting, or is it less? So we can drill down to that level of detail because we classify the trains going over it. We can understand that actually this type of train is pulling this amount of force, which is significantly higher than the rest for whatever reason that is. So yes, Les, if you want to chat about that, give me a call, mate, and we'll go through it.
Great. Thanks, Matt. We're getting to the end of the questions almost. There's a final couple. Nick Ramsden has asked, do you have any metric data of where the analysis led directly to maintenance teams intervening? And does the Conic system supplement the PLPR data and result in better prediction of degradation?
Lily, do you want to take the first bit and I'll do the PLPR bit if you want?
Sounds good. Great teamwork. Okay, so to address the first bit, yes, actually. So we have like a live KPI dashboard where we track exactly, okay, what warnings were issued, or like how is the reliability score doing? Was any action taken by the user? Was the asset inspected? Was some maintenance done? Was some exchange done? Maybe. We track all of these. Of course, the information available to us from our customers is not always perfect because, of course, the customers are busy. We don't always get the data in time. But as soon as we get it, we automatically ingest it into our KPI dashboard, and we are generating a report of, okay, in this many cases, this was actually a false alarm, or in this many cases, we actually cut the alert right in time. In this many cases, we actually informed longer term planning. So this information is available to us. I'm actually not sure if I'm allowed to share it publicly. So if you're interested, please feel free to reach out to us. And we are more than happy to share with you some of the success stories, maybe some examples. Yeah.
And then regarding the PLPR stuff, obviously PLPR looks at the plane line more than the S&C units. This is why we're kind of doing that collaboration with One Big Circle, because they've got those trains specifically looking at S&C. So it's a very similar thing, but for the S&C. We have looked at PLPR data, and obviously going back to my answer from earlier, any data sets we can bring together to give us a better understanding of the whole system is going to make everything from prediction to making decisions to degradation planning better. I know we're running out of time, so that was a quick answer, but yeah, would be the answer.
Really appreciate it, both. Thanks.
And as we're at 29 minutes past, I'm going to say that unfortunately we can't go to the last question, but I just really wanted to say thank you to Lily and Matt for the really insightful and informative presentation, as well as taking the time to go through all of those questions. I feel like we got through quite a lot, but if you do have any further questions that you want to ask our speakers, or would like to carry on the conversation, there is a dedicated discussion post, or there will be, on the PWI LinkedIn page, so do look out for that. And then finally, just another reminder, as I did at the beginning, of the upcoming events. The next Lunch and Learn is on the 14th of October. How can we limit wear on key rail infrastructure components? And another reminder of the track renewal seminar that's taking place the 5th of November at the University of Birmingham. And that is going to be all around working together to make track renewals affordable. Thanks again, Matt and Lily, and I wish you all a great afternoon.
It was a pleasure. Thank you so much, everyone. Have a good day.
Thank you.
Thank you, everyone.